Have you seen those AI videos popping up all over the place? I mean, some are so realistic, it's kind of freaky.
Yeah, they really are something.
And a lot of you have been asking, is it like real? Do these AI models actually get the physics behind the stuff they're showing, or are they just really good at copying what they've seen?
It's a really good question, and to be honest, it's a tough one to answer.
Right.
But luckily, Google DeepMind actually created this thing called Physics IQ, and it's supposed to help us figure this out.
Okay, physics IQ. So like an IQ test, but for physics.
Yeah, pretty much. It's a benchmark specifically designed to test an AI's understanding of physics, but like in a way that goes beyond just how realistic the visuals are.
Okay, I'm intrigued. I gotta know, how does that even work?
So basically, they show the AI a short video clip,
Okay.
and then they ask it to predict what's going to happen next.
Uh-huh.
And that way, it can't just copy what it's seen,
Mm-hmm.
right? It has to actually show that it understands how things would play out in the real world.
Ah, so it needs to know, like, how gravity works or how liquids move, that kind of thing.
Exactly. And, this gets to the heart of a big debate in AI right now.
Oh, yeah.
Some people are saying, look, if an AI can predict the next frames in a video, it must understand physics on some level.
Right, because it can't just guess how a ball will bounce
Yeah.
or, like, how a glass will break if you drop it.
Exactly.
Yeah.
And it's kind of like how our brains are constantly predicting what's going to happen next based on what we know about the world.
Right, like, our senses are always feeding us information, and we use that to anticipate what's coming.
Yeah, that's a great comparison. But of course, not everyone buys this argument.
Oh, there's pushback.
Oh, yeah, there are definitely some skeptics out there.
What do they say?
Well, they argue that, look, just because a video looks real doesn't mean the AI really gets the why behind it.
Mm.
Like maybe it's just really good at spotting patterns without actually understanding cause and effect.
Right, right. It's like confusing correlation with causation. Just because two things happen together doesn't mean one causes the other.
Exactly.
Mm.
And to make things even more complicated, a lot of the research in this area up until recently used synthetic data sets.
Synthetic, so like fake videos.
Basically, yeah, videos created by computer simulations.
Huh.
And the problem with that is the AI could be, like, cheating by learning the quirks of the simulation,
Yeah.
not real-world physics.
Oh, that's interesting. So it's not really a test of how it would perform in our messy, unpredictable world.
Yeah, you got it. And that's where Physics IQ comes in.
Okay, so what's different?
They use real-world videos for their tests,
Oh, okay.
and they cover a whole range of physics concepts.
Like what?
We're talking how solid objects behave, how liquids move, how light works, heat, even magnetism.
Whoa, okay, that's a lot more than I was picturing. So how does this physics IQ test actually work? Do they just show the AI a clip and say what happens next?
It's a little more structured than that. So the AI sees a few seconds of video and then has to predict what happens over the next 5 seconds.
Got it.
And here's the really clever part. A lot of the scenarios are actually designed to be unusual or like unexpected.
Oh, why is that?
Well, it helps test if the AI truly understands what's happening, not just memorizing common patterns.
Ah, I like that. So it's like giving it a trick question to see if it can really think on its feet or think on its processors, I guess.
Right. Like imagine a video of a domino chain falling. Pretty basic, right?
Yeah, classic domino effect.
Exactly. But what if they put like a rubber duck in the middle of the chain?
Okay, now things are getting interesting.
Right. Suddenly, the AI can't just rely on dominoes falling in a straight line.
It has to figure out how that rubber duck is going to mess things up.
Exactly.
It needs to understand cause and effect, not just like dominoes equals falling over.
Yeah, exactly. Now, you might be wondering, how do you measure something like understanding in an AI?
Right, like you can't exactly measure it with a ruler or anything.
Yeah. So they actually use 4 different metrics, each looking at a different aspect of understanding.
Okay, break that down for me.
So, for example, does the AI predict the action in the right place? Does it happen at the right time? Does it predict the amount of action correctly? And finally, does it all look realistic? Like, are things moving and interacting in a way that visually makes sense?
So they're looking at like location, timing, intensity, and even the visual details of how things interact.
Exactly. And the results? Well, they were kind of surprising.
Oh, in what way?
Even the most advanced AI models only scored, get this, 24.1% on physics IQ.
Wait, 24.1%? That's not what I was expecting at all. I mean, some of these AI videos look so real. I thought they'd score way higher.
It's a real eye-opener, isn't it? It shows just how big the gap is between making a video look realistic and actually understanding the physics behind it.
Wow, yeah. So even if an AI video looks incredibly convincing, it doesn't necessarily mean it's based on a real understanding of the physical world.
Exactly. And here's the kicker. There's actually no correlation between how realistic a video looks and how well the AI understands the physics.
Wait, seriously. So an AI could make a video that's basically indistinguishable from a real video, but still completely bomb the physics IQ test?
Yep, that's what they found. Really makes you think about what understanding even means when it comes to AI.
It really does.
Yeah.
Clearly, it's about more than just making a believable visual.
Right. It's much
Yeah.
deeper than that.
So do you have any specific examples from this research that really illustrate this?
Oh, absolutely. Let's take a look at Runway Gen 3, this AI that makes these amazing-looking videos.
Oh, yeah, I've seen some of their stuff. It's really impressive.
So they showed a video of a burning match being dipped into a glass of water.
Okay, I can picture that. We all know what's going to happen. The flame's going to go out.
Right. But guess what Runway Gen 3 did?
What?
As the match touched the water, a candle appeared and was lit by the match.
Hold on, a candle just like magically appeared. That's definitely not how fire works.
Exactly. High visual quality, zero physics logic.
Wow. So it's like, even though it looks like it's being creative, it's really just remixing visual elements seen before without actually getting the cause and effect.
You got it. And then there's Sora, another AI that makes hyper-realistic videos. And even though it's visually incredible, Sora kept putting in these video cuts, even though it was specifically told not to change the camera angle.
That's weird. If it understands the scene, why would it do that?
Well, that's the big question. Researchers think it might be because of the training data,
Oh, so maybe the videos it learned from just had a lot of cuts, so it picked up that that's a normal way to make a video, even if it doesn't make sense in this particular scene.
That's the idea. It's like,
Yeah.
even though it can create amazing visuals, it's still stuck on what it's been trained on, not really thinking for itself.
Huh. That is interesting. So even the best AIs aren't perfect. They still have these quirks and limitations.
Oh, absolutely. It just highlights how tricky it is to make an AI that can apply its knowledge to totally new situations.
Yeah, totally. But wait, it can't all be bad news, right? There must be some cases where the AI models showed signs of understanding.
Oh, there were definitely some. For example, there's this model called Video Poet, and it was able to accurately simulate how paint would smear on glass.
Oh, wow, that's pretty cool because it has to get how the paint and the glass would interact.
Right. And some models were able to figure out where the action should be happening, even if they got the timing a little off.
So there's hope. It's like they're showing glimmers of understanding, even if they're not quite there yet.
Exactly. We're definitely seeing progress, but we're still a long way from AI that truly grasps physics.
It sounds like we're just starting to understand how to build an AI that can really handle the complexities of the physical world.
I agree, and research like this is so crucial because it helps us separate the hype from the real progress and pushes us to ask the right questions about what AI can actually do.
So what does all this mean for you, the listener? What's the takeaway?
I think the biggest takeaway is don't just assume that a video looks real, means the AI understands what's happening.
Right. Don't let the flashy visuals fool you.
Exactly. Don't be afraid to ask critical questions about what the AI can really do.
We've covered a lot of ground here, but it feels like there's so much more to explore.
Oh, there definitely is. And this research raises a really interesting question.
Oh, lay it on me.
What if AI keeps getting better at physics, but just by predicting what pixels come next, does that mean it's experiencing reality as just one option out of many possibilities?
Oh.
Or does it need something more? Like, does it need to actually interact with the real world to truly understand?
Ooh, that is deep. Like, is real-world experience necessary for genuine understanding? Almost makes you wonder, are we in a simulation?
Right. It's a question that philosophers have been debating for centuries, but now it's relevant to AI too.
That's mind-blowing. I am definitely hooked. I can't wait to dive deeper into this.
Yeah, it's a pretty wild thought, isn't it?
It really is. That idea of AI maybe seeing reality as just one possibility out of like a whole bunch of options really stuck with me.
Yeah, it's fascinating.
Especially when you compare it to how we experience the world, like we can imagine different outcomes, but ultimately we're kind of stuck with the laws of physics as they exist in our universe.
Right. And that's a key difference, isn't it? We have this physical experience in the world.
We're not just thinking about it, we're actually in it.
Exactly. We interact with it and we learn from the consequences of our actions.
It's not just passive observation like we were talking about with some of those AI models.
Exactly. And it makes you wonder, like, is that kind of physical experience actually necessary for truly understanding physics?
Hmm.
Or any aspect of the world for that matter?
That's a really good question.
It's something that researchers are really starting to explore.
Oh, yeah.
Yeah, there's this whole growing field of embodied AI.
Embodied AI. Okay, I'm not familiar with that one.
So basically, it's where you have robots or like virtual agents actually learning by interacting with their environment.
Oh, interesting. So it's not just about feeding them data, it's about letting them like move around and experience things firsthand.
Exactly. It makes sense, right? It's kind of like the difference between reading about how to ride a bike and actually getting on one and experiencing it.
Oh, yeah, totally. You can read all the books you want, but until you actually feel that balance and momentum, you don't really get it.
Exactly. There's this level of like intuitive understanding that comes from actually doing it.
That might be impossible to get just from data alone.
Right.
So, as AI keeps evolving, do you think we'll see a shift toward more of these embodied learning approaches?
I think it's inevitable, to be honest.
Hmm. Why is that?
Well, if we want AI to really understand the world and not just make pretty pictures,
Uh-huh.
we need to find ways for it to actually interact with that world.
To experiment, make mistakes, really learn from experience.
Exactly. And who knows what kind of breakthroughs we might see when AI is no longer just a passive observer, but an active participant.
It's exciting to think about what kind of things could an AI that actually understands physics do? Like, how could it change the world?
It's really hard to say for sure, but the possibilities are pretty mind-blowing.
Yeah, that's true.
But, for now, I think it's important to remember that these AI models, as amazing as they are still just tools.
Right.
And like any tool, they can be used for good or for bad.
It's not the AI itself that's good or bad, it's how we use it.
Exactly. And it's our responsibility as humans to guide their development and make sure they're being used to benefit society.
Couldn't agree more. It's so easy to get caught up in the excitement of the technology, but we can't forget the human element here.
AI is ultimately a reflection of us, our values, our goals.
Right. Our biases, too, unfortunately.
Absolutely. And that's something we have to be mindful of.
Like, what kind of data are these models being trained on? Are there any hidden biases in there that we need to be aware of?
Yeah. And what are the potential consequences of their actions,
Hmm.
especially as they become more powerful and more integrated into our lives?
Okay, so we've talked about those big picture questions about what it means for an AI to understand physics
Hmm.
and the potential of embodied AI to really push things forward.
Right.
But I want to dig a little deeper into some of the specific tests that were used in this research.
Oh, sure. Yeah, some of them are pretty clever.
Like, what were some of the more interesting scenarios they used to evaluate these models?
Okay, well, one that I thought was really interesting involved a kettlebell and some pillows.
Okay, kettlebell and pillows. I'm intrigued. Set the scene for me.
So they showed the AI a video of a kettlebell being dropped onto a pillow.
Okay, yeah, I can picture that. The pillow would probably flatten under the weight.
Exactly. But then they showed the AI a similar video, but this time a piece of paper was dropped onto the pillow.
Okay, I see what they're doing there. It's about testing whether the AI understands the difference in mass, right?
Yes. And the forces involved.
Like, the paper isn't really going to affect the pillow much at all.
Right, but the kettlebell is going to have a big impact.
So it's not just about recognizing objects, it's about understanding how those objects would interact based on their physical properties.
Exactly. Did they get it right?
Well, some did better than others.
Yeah.
The ones that showed a deeper understanding were able to, like, accurately predict the different outcomes based on whether it was the kettlebell or the paper.
Interesting.
But others, they kind of struggled to differentiate between the two.
So it's like some AI models are starting to develop a more refined understanding of those physical properties, but there's still a lot of variation in how well they can do it.
Yeah, I guess that's to be expected, right? They're not all at the same level.
Right, and that's what makes this research so valuable.
In what way?
Well, it highlights the areas where AI is still falling short.
Shows us where we need to focus our efforts.
Exactly. Helps to guide those future research efforts.
I'm also really curious about the scenarios involving liquids.
Oh, yeah. Those are tricky.
Because liquids are so hard to simulate realistically, right?
Yeah, fluid dynamics is incredibly complex.
So what kind of liquid-based challenges did they give the AIs?
One example was a pitcher of liquid being poured into a glass.
Okay, pretty straightforward. The liquid would just flow from the pitcher to the glass.
Right, but then they made it more challenging.
How so?
They tilted the glass at different angles or changed the pouring speed.
Ah, I see. So they're trying to see if the AI can predict how the liquid will behave under different conditions, like if it'll spill or splash.
Exactly. It's not just about generating a static image of a glass with liquid in it.
It's about capturing the dynamics, the movement.
Exactly. And how did the AIs do? Well, it was a mixed bag, like with a lot of these tests.
Some got it, some didn't.
Yeah, some models were able to generate pretty realistic simulations, even with the tilted glass and stuff.
Okay.
But others, they really struggled. The results ended up looking weird or just didn't make sense physically.
So, like, with a lot of these physics concepts, AI still has a ways to go when it comes to liquids.
Oh, definitely. It just highlights how much more work needs to be done.
Hmm.
You know, we need better algorithms, better training methods, especially for dealing with this kind of complex stuff.
Yeah, it's really fascinating to see just how much AI is still struggling with these seemingly basic physics concepts.
It's humbling in a way, isn't it?
It is. It makes you realize that there's so much more to AI than just creating cool visuals or impressive demos.
Yeah.
It's about developing a real understanding of how the world works, and we're only just scratching the surface of that.
Yeah, we're all on this journey together. As AI keeps evolving, it's going to impact all of our lives.
And it's up to us to make sure it's a positive impact.
Couldn't agree more. We need to be mindful of the potential downsides, but also embrace the incredible possibilities.
Okay, so we've explored the challenges, we've talked about the potential of embodied AI, but before we wrap up, I want to touch on one last thing.
Okay, what's that?
I think it's so important for our listeners to think about this, and it's all about critical thinking in the age of AI.
Oh, yeah, that's crucial.
Because as these models get more sophisticated and their output becomes more common,
Mm-hmm.
it's more important than ever for us to be able to tell fact from fiction, you know?
Absolutely. Don't just believe everything you see.
Exactly. We need to be questioning assumptions, carefully evaluating the information we're presented with.
Yeah, like where did this information come from?
What are the biases of the AI that made it? Does it line up with what I know about the world?
And what are the potential consequences of just taking this information at face value? Like, how could it affect my decisions?
Oh, those are such good points.
Yeah.
It's about having that healthy skepticism, not just blindly accepting everything AI throws at us.
Right. And recognizing that AI, like any technology, it's just a tool.
It can be used for good or bad. It depends on us.
Exactly. We have to use it wisely and responsibly.
Well said. We're getting close to the end of our time for this part, but honestly, it feels like we've only just scratched the surface of this whole topic.
Oh, yeah, for sure. There's so much more to explore.
Before we move on, is there anything else you'd like to leave our listener with? Anything they should keep in mind as they navigate this world of AI and all that it can do?
I think the most important thing is to approach AI with both a sense of wonder and caution.
Okay, I like that.
Embrace the possibilities.
Yeah.
AI is capable of some incredible things,
Mm-hmm.
but don't lose sight of those critical thinking skills.
Don't get so dazzled by the shiny tech that you forget to think for yourself.
Exactly. Stay curious, stay informed, and stay engaged in the conversation, because this is something that's going to affect all of us.
Couldn't have said it better myself. So let's take a moment to absorb everything we've talked about so far, and then we'll jump into the final part of our deep dive into physics and AI. All right, welcome back to the deep dive. We've been on quite a journey exploring the world of AI and, how it's grappling with physics.
It really has been quite the exploration, hasn't it?
Yeah, from those domino chains and like the rubber duck example to kettlebells and glasses of water, it's clear AI's got a lot to learn about how our universe works.
I think the biggest surprise for me, at least, was realizing that, just because an AI can create a video that looks super realistic doesn't necessarily mean it actually understands the physics behind it.
Right, it really makes you question what we even mean by understanding, especially when it comes to AI, right?
Absolutely. It really does. And it leads to some pretty big questions about where this whole field is headed.
Yeah, like, can AI ever really get a grasp on physics, a deep understanding, just by getting better at predicting what pixels should come next in a video?
Right. Or is there a limit to what it can learn just from data? Will it need something more of I don't know, will it need to actually interact with the world?
Yeah, experience the consequences of its actions, learn cause and effect in a more hands-on way.
Exactly. And that's a question with some pretty big implications for how we develop and use AI in the future.
No kidding. It makes you wonder if there's some kind of fundamental difference between, like, learning from data and learning from experience.
Yeah, is there something special about that real-world interaction that you just can't get from passively observing?
Exactly. And I'm starting to think there might be.
It's a really intriguing possibility.
It is. And it's definitely something we need to think carefully about as we create these increasingly powerful AI systems.
We can't just get swept up in all the cool stuff AI can do.
Right. We have to stay aware of their limitations, the potential biases they might have, and think about the consequences of their actions in the real world.
All very important considerations.
For sure. But, even with all that said, I do want to acknowledge the incredible progress that's been made in AI, even in just the past few
Oh,
years.
yeah, absolutely. It's mind-blowing how quickly things are moving.
It really is. The models we've been talking about, they might not be perfect,
Yeah.
but they can do some truly remarkable things.
It's such an exciting time to be witnessing this whole evolution of AI,
Mhm.
and seeing how it's changing the world around us.
It really is. So, as we wrap up this deep dive, what are your final thoughts for our listeners? What should they take away from all of this?
I think the most important thing is just stay curious, stay informed, and stay engaged in the conversation about AI. It's such a powerful tool, and it has the potential to completely reshape our world in
Oh,
both good and bad ways.
it's not something we can just ignore, right?
Exactly. It's up to all of us to be a part of this conversation and make sure AI is being developed and used in a way that benefits all of humanity.
Well said. And remember, everyone, just because an AI can create something that looks amazing doesn't mean it truly understands what it's doing.
Keep those critical thinking skills sharp.
Ask the tough questions and use your own judgment to navigate this whole crazy, rapidly evolving technological landscape. Thanks for joining us on the deep dive, and we'll see you next time for another deep dive into a fascinating topic.